Okay, today we have discussed classification of reactions involved in volumetric analysis. Reactions which are involved in volumetric analysis. Now the first reaction is called neutralization reaction. As all of you know that what is the neutralization? Neutralization means an acid and base react to each other and it forms salt plus water. And this is called neutralization reaction, which always exothermic, means an acid and base react always deplete the amount of energy. So in volumetric analysis, whenever we have used this type of reaction, means whenever we have used substance acidic or basic, then the reaction between them is called neutralization reaction. And this types of titration is also called neutralization titration. This types of titration is also called acidimetry. Is also called acidimetry or alkylimetry titration. Alkylimetry titration. Acidimetry means something related with the acid and alkylimetry means something related with the base. Now the second titration is or second reaction is oxidation reduction reaction. Oxidation reduction is also called redox reaction. As you know that what is the meaning of oxidation? It's the losing of electrons. Losing of electrons called oxidation. Similarly, if we are discussing about reduction, then gaining of electrons. Gaining of electrons called reduction, and whenever a chemical reaction in which oxidation and reduction both are take place simultaneously are termed as oxidation reduction reaction or simply redox reaction. For example, we are taking some example here is when we are taking the example of KMnO4. It is a very good oxidizing agent in the acidic medium. Similarly, we are having the example of potassium dichromate, that is K2Cr2O7. They are also very good oxidizing agent in the acidic medium. So KMnO4 and dichromate both are the very good oxidizing agent in acidic medium. And we are having some another example like ferrous ammonium sulfate, FeSO4 dot NH4 whole twice SO4 dot 6H2O is also called Mohr salt, or simply it is a double salt. It is a reducing agent. So if we are taking the example of KMnO4 with the ferrous ammonium sulfate or Mohr salt, then what happened that KMnO4, its color is violet, react with ferrous ammonium sulfate, it's a colorless compound, and this reaction performed in the acidic medium, that is in presence of the dilute H2SO4, that is also colorless. Now after the reaction, what happened? This KMnO4, in this KMnO4, the OS, that is oxidation state of the MnH plus 7, and in this FeSO4, the OS of the Fe, H plus 2. Now what happened? When KMnO4 and ferrous ammonium sulfate react to each other in the acidic medium, then KMnO4, that is a very good oxidizing agent, oxidizes the ferrous ammonium sulfate, that is Fe plus 2 into Fe plus 3, and at that time the ferrous ammonium sulfate reduces manganese plus 7 to plus 2. So here is the Fe reduces the manganese and manganese oxidizes the iron. Now after the reaction, here is we are obtain Mn plus 2, that in the MnSO4 form, and in the MnSO4 the OS of the manganese becomes plus 2 and the other compound is Fe, that is oxidized into plus 3. So the compound becomes ferric sulfate. The compound becomes ferric sulfate. Fe2SO4 whole 5. So in overall reaction, the plus 2OS of the Fe converted into plus 3OS. It means in overall reaction, Fe is oxidized and KMnO4 reduced to plus 7 to plus 2 OS. So in this reaction, here is the simultaneously oxidation reduction occurs. So that's why it is called redox reaction. And whenever we are using this types of reaction in a titration or volumetric analysis, this one is called redox titration. Now, third reaction becomes, after discussing the third reaction, in the reduction reaction, we are balancing the reaction. For example, if we are taking the example of KMnO4 and we are taking the KMnO4 in its ionic form. We are taking the example of KMnO4 in its ionic form, then MnO4 negative. Here is the OS of the manganese is plus 7. In the acidic medium, it directly goes into Mn plus 2. And Mn plus 2 is the colorless. The sign becomes colorless. And this one is the violet color due to charge transfer spectra or CT spectra. Here is the Mn plus 2 is colorless due to stable d5 electronic configuration. Now we are balancing, if we are balancing of this reaction, then we got, here is the difference between electron is 5, that is called n factor. Here is the n factor becomes 5. Now if we are balancing of this, then here is plus 7 converted into plus 2. So first we have balanced the other element except oxygen and hydrogen. Except and hydrogen, other element becomes manganese, that is balanced of both of the side. Means left hand side 1 manganese. Similarly, right hand side also 1 manganese. Now we have balancing the oxygen. We see that left hand side we are having 4 oxygen, but right hand side we don't have any oxygen. So for balancing the oxygen, we are using H2O. So for balancing H2O, we are adding 4 H2O molecules in the right hand side. So right hand side we are adding 4 H2O molecule for balancing the oxygen molecule. Now after balancing of oxygen, we have been observed that right hand side here is the 8 hydrogen, but left hand side not any hydrogen. So balancing of the hydrogen, we are using H plus. So we are adding 8H plus in the left hand side. That becomes 8H plus plus MnO4 negative, and after the reaction we are having Mn plus 2 plus 4H2. Now after balancing the hydrogen, oxygen, manganese, the reaction is balanced in its elemental form. Now we are balancing its charge. If we are seeing the right hand side, then we are having only plus 2 charge. But if we are seeing in the right hand side, here the charge is, that is 8 plus and 1 minus. So total charge becomes, that is 8 plus 1 minus, that in that side the charge becomes plus 7. Now our aim becomes balancing the charge. For balancing the charge, we are using electrons. You know that electron is negatively charged. So for balancing the charge, we are adding how many electrons? That is 5 electrons in the left hand side. So the reaction becomes 5 electron plus 8H plus plus MnO4 negative, and after that we get Mn plus 2 plus 4H2. तो फिर खत्म, सब तेज खत्म हो गया. Now the balance reaction is 8H plus plus 5 electrons plus MnO4 negative. It gives Mn plus 2 plus 4H2. Now the reaction is completely balanced. Here is the manganese single manganese, oxygen 4. Here is the 4 oxygen. Hydrogen is 8. Here is the 8 hydrogen. Now the last is charge. Here is the charge is plus 2. Here the charge is 8 plus and 6 minus. That becomes plus 2. Here is the charge plus 8 minus 6. That becomes plus 2. and here the charge become plus 2. So reaction is completely balanced. Now we are discussing our second reaction. The second reaction becomes Fe plus 2, it undergoes into Fe plus 3. Now here is the not any element for the balancing, that is the balancing only of the charge. This one side charge becomes plus 2 and this one side charge becomes plus 3. So for the balancing of the charge, they are using the electrons on the right hand side. There is the only one electron. After adding one electron, we are having plus 2 charge right hand side and we are having already plus 2 charge on the left hand side. Now this one is the reaction first and this one is the reaction. We see that in reaction first the electron becomes 5 and the reaction second the electron becomes only single. So finally we are combining this first and second reaction. So before combining this reaction or before adding of this reaction, we are multiplying the reaction 2 by 5 by equating the electrons. So this it's a equation number 2 whole multiplied by 5 for balancing the electron in reaction first and second both. So after multiplying this reaction we get the reaction 5 Fe plus 2, it gives 5 Fe plus 3 plus 5 electron. Now that is the reaction third. Now we are adding reaction first and third. The third reaction becomes 5 Fe plus 2, it undergoes 5 Fe plus 3 plus 5 electrons. Here this one side is charge becomes plus 10 and this one side charge becomes plus 15. So we are adding, here is the 5 electrons. Now plus 15 minus 5, that becomes plus 10. That is the reaction third. The reaction first is 8H plus 5 electron plus MnO4 negative, and after the reaction Mn plus 2 plus 4H2O, that is the reaction first. Now when we are adding reaction first and third, the electron cancel out from both sides and the final reaction becomes, that is 5 Fe plus 2 plus 8H plus MnO4 negative. After the reaction we get Mn plus 2 plus 5 Fe plus 3 plus 4H2. So that is the balanced reaction. Now here is the 5 Fe, now 5 Fe, here is the single Mn, here is the hydrogen becomes 8, here is the hydrogen becomes 8 and oxygen, here is the 4 and here is the 4 oxygen. Now finally the balance the charge, here the charge becomes this 5 multiplied by this 3, so we get plus 15 plus 2 plus 15 plus 2, that is plus 17. In that side 5 plus 2, here is the plus 17 and here the charge become 5 into 2, that is plus 10 plus 8, 18 minus 1, 18 minus 1, that becomes plus 17. So here is the balanced form of the redox reaction that occurs between ferrous ammonium sulfate and KMnO4. Now the next reaction is called precipitation reaction. Precipitation reaction. A chemical reaction in which cation and anions combine to form a compound of very low solubility or in the form of precipitate is called a precipitation reaction. For example, we are simply taking the example of barium chloride. We are having one test tube. This one contains barium chloride. It's a barium chloride solution, and when we are adding in this sodium sulfate Na2SO4, then after the reaction we will get a white PPT of BSO4. Its color becomes white. It forms a solid substance that is called white, and another product that is called sodium chloride, which is also colorless. So the titration which are involving of these types of precipitation formation is called precipitation titration. Now the next reaction is called complex formation reaction. Complex formation reaction. is the name indicate that in these types of reaction, here is a forming of complex compound or coordinate compound. Now, these types of reactions are the simply combination reactions in which a soluble uh, slightly dissociate complex ion or compound is formed and the complex compound retain their identity in the solution and have the properties of the constituent ions and molecules. For example, if we are taking the example of copper sulfate, that color becomes blue. It's a blue copper sulfate which reacts with the ammonia or liquor ammonia that becomes colorless, that is NH3 NH3 solution or NH3 solution or aqueous NH3. Then after the reaction we are having a complex compound, this one type CuNH3 whole 4 SO4. So this compound is color becomes blue and this complex is also called Schurter reagent. And we are taking another example of this types of complex reaction, copper sulfate solution, that is the blue color, react with potassium ferrocyanide, which is light green color. This compound becomes potassium ferrocyanide, react with this copper sulfate, and after the reaction we are having a chocolate brown complex. Now we are having a chocolate brown complex, that is Cu2FeCN whole 6 cupric ferrocyanide. It's a precipitate and it's a chocolate brown, and K2SO4 it's a colorless. So in overall reaction, that blue color copper sulfate react with light green color potassium ferrocyanide, and after the reaction it gives a chocolate brown PPT, that is called cupric ferrocyanide, and the another product is potassium sulfate, that is colorless. So the titration in which this types of reaction is called complex formation titration, and this types of reaction is called complex formation reaction. Now we are simply discuss about acid-base titration. Acid-base titration. Now, if we are discussing about acid-base titration, then we are already known then what is the meaning of titration and what is the acid-base reaction or neutralization reaction. So, when we are performing the acid-base titration, first we are deciding the appropriate indicator. Now, first we have discussed what is the indicator range or which types of indicators are used in the acid-base titration. So basically acid-base titration are divided into 4 categories. The first becomes if we are having a strong acid, Sa. Here is the Sa means strong acid plus strong base. Here is the Sp4 strong base. So if we are taking of the example strong acid like HCl, there is strong acid, and the strong base like NaOH. So when we are using in the titration the strong acid HCl and strong base sodium hydroxide, then it is called strong acid and strong base titration. In this titration the equivalence point lies in the pH range of 4 to 10. So in this titration the pH range becomes 4 to 10. So we are using any indicators like simple methyl orange that we are already discussed, that is MEOH. It's a methyl orange, or phenolphthalein that gives pink color in basic medium, that is HPH. It is the phenolphthalein. So we are using any indicator methyl orange or phenolphthalein, and we are performing the titration which are having strong acid and strong base, and its appropriate pH range becomes 4 to 10. Now the second category is weak acid plus W for weak acid plus strong base, Sp for strong base. So here is the taking of example of weak acid means if we are the taking example of CH3COH, it's a weak acid, and when it is react with the strong base, that is NaOH, sodium hydroxide, then in this type of titration the pH range becomes, here is the pH range becomes 7.5 to 10. So in this type of titration, phenolphthalein is the suitable indicator, that is HPH. With the suitable indicator for this types of titration. Now the third types of titration becomes weak base. Here is the WA for weak base plus strong acid. If we are taking the example of weak base, then the NH4OH, it is the weak base. When it is react with the strong acid like HCl, then in this titration the pH range becomes 6.5 to 4. So here is the suitable indicator is methyl orange, that is MEOH. Now the last fourth category is we are taking the example of weak acid and weak base. So we are taking the example of CH3COH, that is a weak acid plus weak base, that becomes NH4OH, ammonium hydroxide. In these types of titration, the pH range becomes 7. So no simple indicator can be employed for a deduction of the equivalence point. So we are the different types of acid-base titration, and according to the substance, first we are selecting the indicator, that may be methyl orange or phenolphthalein, and after selecting the indicator, we are starting our titration process.